Hello students, in this video I will go through some examples on how to reduce expressions with fractional exponents. Alright, so the instructions here for the exercises I'm about to go through says that to simplify each of the expression and that your answer should contain only positive exponents with no fractional exponents in the denominator. So let's take a look at what we can do. Okay, so this, let me use a different color. This is equivalent to looking at the denominator here, right? U to the 0th is actually just 1. And then v squared to the negative 1, that's v to the negative 2. The numerator, I have v to the, or u to the negative 1/4, v to the 3/4, u to the 0th, which I'm not going to write because that's just 1, and then v to the negative 7/4. Okay, so I'm looking at this now, and I see that there's a lot of v's that I can combine, right? So I have v to the 3/4 and v to the negative 7/4. If I add the exponents together, I will end up with negative 4/4, right? Or just v to the negative 1. So I end up with u to the negative 1/4, v to the negative 1 over v to the negative 2. Next, I have u to the negative 1/4, well, v to the negative 1 over v to the negative 2. That just becomes v to the first, because negative 1 minus negative 2 is positive 1. Now I'm at the stage where I have u to the negative 4 times v. This is equivalent to v over u to the 1/4. And the instructions here says that my final answer cannot contain any fractional exponent. This was mentioned in, I forget how many videos ago, when I first described how we operate or manipulate expressions involving exponents, right? And I made the analogy that just like in your English class, right, there is a way for you to communicate your ideas in a more eloquent manner where you can, so things like, avoid using double negatives or avoid using the same words within the same paragraph, right? So there's something similar to in the discipline for math. Here it says no fractional exponent. This is not like it's not like you're breaking any laws or rules of mathematics if you do leave your answer in this form. However, it does look a little nicer, okay, if your denominator does not contain any fractional exponents. So how are we going to get rid of those fractional exponents? Well, if you look at u to the 1/4 here, I want to turn that exponent into an integer. So what would I have to multiply u to the 1/4 by? I would have to multiply it by u to the 3/4, both in the numerator and denominator. Why 3/4? Because 1/4 is 3/4 away from being an integer, right? So therefore, this becomes u to the 3/4. Hold on, I'll write it like this. U to the 3/4 times v all over u. So that would be the solution to question 1. Let's try the next one. Okay, so b to the 0th, that's just 1. I have a and a to the negative 2 in the denominator. So the whole denominator becomes a to the negative 1st, b to the negative 1, and the numerator is a to the 4/3. Are there any things that I can combine together? Absolutely, because I have 4/3 and negative 1 here. So a to the 4/3 minus negative 1, that is equivalent to 7/3. And b to the negative 1, well, b to the negative 1, that's just going to be a to the 7/3 times b. right? Because you can also think of it as b to the 0th minus, or b to the 0th over b to the negative 1. So 0 minus negative 1 becomes b to the 1st, right? Okay, let's take a look at another one. Ooh, boy. All right, so I want to raise this to the 4th power. So I can do a couple things. I can just distribute the 4 all the way through before simplifying, or I can simplify it and then distribute the exponent. So I think what I'm going to do is I am going to simplify this, the inside the parentheses first. I'm seeing that there's a whole lot of m's everywhere, right? So let's try to clean up the numerator first. So m to the negative 3/2, m to the negative 2/3. So that would be m to the, let's see, negative 3/2 plus negative 2/3. Notice I'm doing the scratch work on the side here. What is that equivalent to? That is equivalent to negative 9/6 plus negative 4/6. That's negative 13/6. And then n to the 0th and n to the 1/4, well, that's just n to the 1/4 then. Over m to the negative 2, n to the 3/4. All to the 4th power. All right, and I'm almost there. I'm going to get rid of that. Okay, now I'm going to simplify the numerator and denominator because I see here I have 1/4, n to the 1/4 and n to the 3/4. That would be equivalent to n to the power of negative 2/4 or negative 1/2. M to the negative 13/6 minus negative 2. Notice I'm again doing the scratch work on the side. So this is negative 13/6 plus 2 over 1. So to create a common denominator, I want to multiply by 3 over 3. So that would be negative 13 plus 6 over 6. That would be 9. No, I'm sorry. That would be 7/6. Negative 7/6. So that would be m to the negative 7/6. And all of this to the power of 4. Finally, I'm going to distribute the 4 through. So I have m to the negative, let's see, 7/6. That becomes 14 thirds. I'm sorry, 14 here. 7/6 times 4, right, is equivalent to 14 thirds. And then n to the negative 1/2 times 4 is negative 2. So remember, no fractional exponents in the denominator. So we're going to have to clean this up. Whoops. We're going to have to clean this up. So the only thing that we have to quote-unquote clean up is the m to the 14 thirds because that is the only part that has a fractional exponent in it. So we got to think about, okay, what number do we add to 14 thirds so that it will become an integer? And if you're thinking adding 1/3, you're absolutely right. So I'm going to multiply both the numerator and denominator by 1/3. So I forgot to mention the very act of us doing this, there's a name for this. And what we call, what this very act is called is rationalizing. We're rationalizing the expression. Why is it called rationalizing? Well, that's because the exponents are now, or the denominator is now rational because we're not taking the square roots of anything. It's going to be a whole integer exponent. So 15 thirds, that's to the 5th power, and n squared. So m to the 1/3 over m to the 5th. Write a little better. N squared. So here is that problem in its entirety again.